Hello, Mathematician students. Today's lesson is 3.4 and we are going to learn about direct variation. Your new vocab word for today is direct variation, and it's an equation in the form of y equals kx. We're going to be doing a lot with that equation today. Example number 1, it's slope and constant of variation. Notice how it says slope and constant of variation because technically they are the same thing. Name the constant of variation for the equation, then find the slope of the line that passes through the pair of points. Well, we are going to follow the slope formula, y2 minus y1 over x2 minus x1, and I'm going to use my points here's my y2, so 2 minus 0 over 1 minus 0, and they get a slope of 2. So the constant of variation is 2, and the slope is also 2. They are the same thing. So again, another example, find the slope of the line that passes through the pair of points and name the constant of variation. Well, y2 minus y1 over x2 minus y1, negative 4. This time, they're just showing you that they can move upward. So negative 4 minus 0 and 1 minus 0 still will give you the same answer of negative 4. So our constant is negative 4 and the slope is negative 4. It is the same point. So we're already to our multiple choice question. So the same rules apply. This is still the same example, but taking a look at the graph, can you tell me what the slope is and the constant of variation? Record your answer and save it for the Google form. All right, example number 2, we are actually going to start graphing today. We have y equals negative 3 over 2x. Whoops. All right, so what we need to do is y equals kx. My k is represented by negative 3 over 2. And direct variation equations always go through 0, 0. So you're always going to start by making a point at 0, 0. And then from there, you are going to follow the rules of rise over run. In this case, it's negative 3 over 2. So I'm going to start at 0, 0, and notice how they went down 1, 2, 3, and over 2. And that is your second point. Once our 2 points are made, we can draw our line, and we have started to graph direct variation of y equals negative 3 over 2x. So checkpoint. Pause the video. We'll come back together and see if you can graph y equals 2x. All right, so I know that I'm going to start at 0, 0. So right off the bat, I know that these equations all will go through the origin of 0, 0. Now rise over run for this one is 2, which written as a fraction is 2 over 1. So that means I'm going to start at 0, 0, and now I'm going to go up 2 because it's positive and over 1. So I've made my 2 points. Now because it's a constant of variation and my slope is going to be the exact same every time, I also can go down 2 and to the left run. And notice that my graph is consistent and it goes through the origin of 0, 0. My slope is up 2 over 1, but again, you can also go down 2 into the left one, and your graph will still be consistent. So just a concept summary, direct variation equations are in the form of y equals kx. K can never be 0. Our slope is not 0. And they always pass through the origin of 0, 0. If the slope is positive, our graph will go in a positive direction, remember from slope aerobics, and if our slope is negative, it would be going in a negative direction. Remember, a positive slope is something like 3/2. They're both positive. Negative slope would be where one of your rise or your run is negative. So this would be an example of a negative slope and a positive slope. All right, so that was example kind of 1 and 2 with graphing and finding the slope or the constant of variation. This is the last example, and we are going to write and solve a direct variation equation. So it says, suppose y varies directly as x and y equals 9 when x equals -3. Write a direct variation equation that relates to x and y. So the first thing that we need to do is find the value of k. We have y equals kx as our formula. So I'm going to plug in my x and my y that they give me in my original equation or my original problem. Then we're going to solve for k. So simply just dividing each side by a -3 will give us -3 for our k or our constant. So the direct variation equation is y equals -3x. Now it says use the direct variation equation of y equals -3x to find x when y equals 15. So again, back from the previous example, y equals -3x was our original equation. Now I'm going to substitute y and solve for x. X ends up being -5, so therefore x equals -5 when y equals 15. All right, we're at a checkpoint. If you want to try this one yourself, go ahead and pause the video. I'll come back in a few seconds and answer it with you. All right, so we have 2 parts to this problem. This is the first part that I'm going to look at. So y equals kx. Basically what we're doing is we're going to substitute y for -11. K stays the same, and I'm going to multiply it by 6. So now I'm going to divide both sides by 6, and my k equals -11/6. So my equation is y equals -11/6x. This is my direct variation equation. So now I'm going to plug it into the second part of the problem. So I have y equals -11/6x. And it says find x when y is 44. So 44 equals -11/6x. Well, in order to get rid of my multiplication or multiplied by x, I need to divide, which basically means multiplying by the reciprocal of 6/11. So give me 1 minute. Just going to grab a calculator. 6 times 44 divided by -11 gives us -24. So what does that tell us? That means that x is at -24 when y is at 44. So there are 2 parts to the problem. The first thing you need to do is find out what k equals, and then use that formula to plug in either x or y to solve for whatever they give us. Find x or find y. So I'm going to have you try one now. It says suppose y varies directly as x. Write a direct variation equation that relates to x and y, and then solve. So just a couple reminders. It's a 2-part problem. You are going to first use this to find your formula for y equals kx. You're finding what k equals. Then you're going to use this formula to now find y when x equals 32. So go ahead and try it. We'll do some more practice with it on Monday when you get back from school. Have a fabulous weekend and stay mathematicious, my friends. I will see you next week.